Right, today we're going to have a look at how to graph a logarithmic function. The difference between a log function and an exponential function is that one is the inverse of the other. Okay, so with an exponential function we have a horizontal asymptote. With a log function we have a vertical asymptote. Alright, let's have a look at the first one. It says y equals log base e of x take 2, and I like to write that as ln x take 2. Now, our form of a log equation is this. So we have y equals a ln b to the x take c plus d, small d, and our a value will be our dilation factor, so how stretched it is parallel to the y-axis. Our b value will be another dilation factor, and that will be how stretched it is parallel to the x-axis. Our c value will be our horizontal shift, and our d value will be our vertical shift. Okay. Our c value, because it's our horizontal shift, tells us where our vertical asymptote is. So horizontal shift, and that tells us where our vertical asymptote is. Okay, now remember, with any of these horizontal shifts, if it's x take 2, our asymptote will be at positive 2. Okay, so we're going to start with our asymptote. Excuse me. At x equals 2. Okay, and that means that I have a domain beginning at 2 but not including 2, remember, because it's an asymptote. So my domain is going to be from 2 with a round bracket to positive infinity, also with a round bracket, and my range will be from negative to positive infinity. So it would be all real numbers. Okay, so let's sketch in an asymptote. I'm just going to extend this line a little bit. Okay, so there's my x, there's my y. Okay, so we have a vertical asymptote at x equals 2, and we always sketch that in with a dotted line, and we label it. Alright, now we need to figure out the shape of this thing. Okay, my a value is positive, my b value is positive, so this is not reflected about the x or the y axes. Okay, so let's try and see if we can find an x-intercept. So our x-intercept happens when y equals 0, so we have 0 is equal to ln of x take 2. Now remember, ln is log base e, so e to the 0 is x take 2. I'm rewriting that into exponential form, and e to the 0 is always 1. So 1 plus 2 is equal to x. X equals 3. So my x-intercept will be at 3 and 0. Cool, so I've got a point. There we go, 3 and 0. Now, I know from my equation, and it's a positive log graph, I'm expecting something that looks a little bit like that. But I don't have any idea about the shape or anything. So I'm going to pick another logical point. Now, you can choose that point. It doesn't matter which point you choose. But if you pick your point carefully, you'll get a nice round number. So if I have a look here, this is log of x take 2. Okay? So if I chose a value of, let's say e plus 2 for x. Let's have a look at that. When x equals e plus 2. Now I know that e is around about 2.7. So e plus 2 will be 4.7-ish. Okay. And I substitute that in. I get y equals ln of e plus 2 minus 2. And I guess the cool thing about that is that the 2's cancel and I get ln e, which is 1. Okay. And that then gives me a point e plus 2 and 1. Okay. And I know around about 4.7, so that will be somewhere there and 1. Okay, and that gives me my e plus 2 and 1. And now I've actually got another point to give me my shape. Okay, so I've got my asymptote there. I'm going to go through that point, and that's my graph. Okay, so y equals ln of x take 2. I could have selected any other point. I could have said x equals 4, and then I would have had a point 4 and ln 2. You'd have to kind of guess a little bit what ln 2 is. It just depends. Doesn't really matter which one you choose, but I like to pick a logical point.